Hello. One-to-one functions are Unit 2, Lesson 5, page 17. I already tried this once, and it didn't record my voice for some reason, so we're doing it again. Giving up my lunch period for you guys. So one-to-one functions. Functions, rules, I'm up here, can be divided, I want that color, into categories based on such character or shared characteristics. So we have functions that are known as one-to-one. That's what we're going to look at today. And we're going to see the difference between a function that is one-to-one and one that is not. So we have two functions that we're looking at. We have f of x, which is 2x, and g of x, which is x squared. Right here, exercise 1. So I'm mapping the domain. So remember, your domain are your x values. So I'm mapping the domain using each function. Fill in the range, right? The range are your y values. So when I plug this domain into the 2x, negative 2 times 2 is negative 4. 0 times 2 is 0, and 2 times 2 is 4. So each one has its own output value. So every input you have its single output value. When I go to the next one, which is x squared, I have negative 2 squared, which is 4. And you have to be careful, because if you put negative 2 without parentheses squared, it'll give you a negative 4, which is incorrect. 0 squared is 0. And then 2 squared is 4. So we already have an output. So if I have a value that is doubled, meaning that I have two y values, then that is not one-to-one. So that is the fundamental difference between these two in part B, and how the elements of this domain get mapped in the elements of the range, that for the f of x, each value in the domain has one value in the range. Whereas the g of x, it has a value in the domain which has the same range value. Okay, so negative 2 gives you 4, and 2 gives you 4. So one-to-one, here's your definition. It's very difficult to understand some of these definitions. So it's called one-to-one if x1 does not equal x2, implies that fx1 does not equal f of x2. In other words, different inputs give you different outputs. All that means is that the x's can't equal, therefore the y's don't equal. Of the 4 tables in exercise 2, one represents a relationship where y is a one-to-one function of x. Determine which it is and explain why the others are not. So the key thing you look at first is always look at a function. So a function has to pass the vertical line test. That means it can only have one x value. Okay, it can't have doubles. So problem 1 or choice 1 has double 4s and double 9s. So therefore, that is not even a function. And the other one was 4. You see how the negative 2 is a double up? So 1 and 4 are not even functions. So we then look at the one-to-one. So, okay, so here 2 and 3, all the x values, they're all single x values. Then for it to be one-to-one, we have to have no duplicates in the y column. So here I am, look at number 2, and you see I have a duplicate of 1. So therefore, that's not one-to-one. When I look at the y values here in choice 3, I have 2, 4, 8, 16, which none of them duplicate. So therefore, choice 3 is your one-to-one function. Now, when I look at exercise 3, I'm looking at the 4 graphs, which show a relationship between the variables y and x. Letter A says, circle the 2 graphs above that are functions. So functions pass the vertical line test. So that passes it, that does not, and this one also passes it. So therefore, circle the 2 graphs, 1 and 4. Explain how you know they are functions, because they pass the vertical line test. Okay? B, of the 2 graphs you circled, which is one-to-one. So one-to-one functions, remember, can only have one single y value. So if I look at the first one, if I'm looking at this y right here, I have a y value here and here. So there's more than one of them, so it can't be number 1. But if I look at all the y values here, in choice 4, that one is going to be 1-to-1 because they only have one output value. So explain how you can tell from the graph. Because there is only one output value for each input value. So remember, if I go too fast, pause it, slow it down. Now the horizontal line test. The horizontal line test tells you if it's 1-to-1. So if I go way back up here, I wasn't going to just read the whole thing to you. So if I go back up here and I do the horizontal line test, look. Okay, it fails the horizontal line test, therefore it is not 1-to-1. This one passes it. Okay, now this one, choice 2, passes the horizontal line test, so it's 1-to-1, but it's not a function. And then 3 is neither 1-to-1 nor a function. So when we get down here to exercise 4, which of the following represents a graph of a 1-to-1 function? Vertical line test first, fails. Vertical line test, good. Vertical line test, good. Vertical line test, good. Okay, so that's your function. 1-to-1, horizontal line test, fails. Fails, okay, because it goes 2 places. Okay, so that choice is choice 3. Oh, that Mr. Basil coming in. Okay, so the last one, exercise 5. The distance that a number x lies from the number 5 on a one-dimensional number line is given by the function d of x equals absolute value of x minus 5. Show by example that d of x is not 1-to-1. So we should know that the absolute value is a v. Now what I did is I put in the calculator. So I put it in the x minus 5 absolute value, I entered it. Okay, there is your v. Now, if I drew a line here, you can see that the horizontal line test will fail. So it's not 1-to-1. So I want to prove that. So I'm going to go to the table and find 2 outputs that are the same. So I just scroll down the table and look, I can do 3 and 7, I can do 4 and 6. So I'm going to do 4 and 6, and the answer should be 1. So I have d of 4 and d of 6. Oh, should we parentheses there? So d of 4 is the absolute value of 4 minus 5, which is the absolute value of -1, which is 1. So my input is 4, my output is 1. D of 6, absolute value of 6 minus 5, is absolute value of 1, which is 1. So show by example, there's my example that it's not 1-to-1 because I have the same output value for a different input. Okay, so I know this might be a little tricky. Hopefully you got it. It's essentially the horizontal line test. So we can go over it again if you have any questions. Of course, we'll go over it in class. All right, we will see you in class.